So hello everyone, welcome to our talk titled Istio Platform versus Spring and MicroProfile Frameworks. I'm Kate Stanley, this is Adam Pilkington, and you may have seen some of our talks before on microservices and cloud-native applications using Spring and MicroProfile, but today we're going to introduce the Istio platform to you all and explain how we think you can use it alongside Spring and MicroProfile apps.
Okay, so a quick outline of what we're going to go through today. We're going to have a look at the evolution of software, of the platform, and of the frameworks, so we can see how and where Istio came from and the gaps it's filling and how it's helping out with development. And this whole sort of platform framework tension and where it's come from. There is a tension, but it's overlapping roles of responsibilities. But you benefit from knowing how we got to this point in time, so you can compare and contrast. Because when we're going over the history, so quick hands up in the room. Anyone do the recent Stack Overflow developers questionnaire? One at the back. 2, yeah, that's great. Anyone read the Stack Overflow developers question? Yeah, far more people were very curious about what was going on. And interestingly, there are a large demographic that are recent software developers, 3 to 5 years. So they may only know the platform and the platform capabilities, and it may be taken as granted. Of course, you could always say that they're also the demographic most likely to fill out online application forms and online surveys. But you have that, and you also have people who've evolved and come with the frameworks. Sort of people like myself have been around for a while, doing software development, have used the frameworks far more perhaps than they have the platforms. And you may, in your mindset, have them as sort of these independent things that sort of sit in isolation. When the reality is, they're converging, they're starting to overlap, they're starting to do some of the same things. So what we had sort of so I'm going to, during this brief history, I'm not going to be chronologically correct. I'm going to sort of just paint some broad brush strokes. But the idea is to recap some of the things that came along that got us to the point where we had something like Istio come along. So we start off with a monolith, and so by monolith, what I'm talking about is an application that was large in scope, did a lot of things, was deployed in your network under your control. I mean, if you look at the amount of specs that are in JEE, these are applications that use a large number of those specs to get their work done. Databases, messaging. There was entity beans, session beans, all sorts of things going on in that space. So you had your monolith, life was good. Then we had the cloud. Now, when we talk about a cloud, what I'm really saying is that there are advances in hardware capabilities, virtualization technologies, to the point where people are starting to, want to use virtualized servers. So, once you have applications that are being deployed into virtual servers and virtual environments, then you might as well have someone else run that hardware for you. So you have a cloud at that point. And so what people did, the first step of this, was they put the monolith into the cloud. Now, we all remember the Java tagline, write once, run anywhere, yeah? Well, not so much when it comes to putting a monolith into the cloud. You remember all of those services we talked about in JE spec? These things were missing when it went to the cloud. This wasn't your environment anymore. The things that you used to reach out for, that used to depend on the services it wanted, the facilities were there, just weren't there with this monolith into the cloud. You couldn't just lift and shift this thing. It didn't work very well. So we had 12-factor come along. So 12-factor was a sort of 12 principles that a group had observed led to the more successful cloud deployments of applications. It included things like having separate code bases, pipelines, process isolation, parity between production and development. So all these things were put together and said, you know what? We have observed that the most successful deployments of the cloud follow these 12 factors. So you had those recommendations people started to follow. And we have microservices as well. So, there used to be the old joke, everyone's talking about microservices. Well, now people are actually doing that. So they're taking their monolith, and they're actually converting it into a number of individual services. Now, they may be doing this via strangler patterns, code refactoring, just onboarding completely new services, whatever. But conceptually, that functionality that used to be taken place inside the monolith now becomes separate microservices. And then what they're doing is they're just deploying these to the cloud, pushing them out. We're just deploying to the cloud at this point. And Docker as well. So typically these are inside Docker containers. Remember this, we wanted this process isolation for 12-factor. We wanted something that I'm developing on my laptop to be the same as what went into production. Well, Docker gave me that. So I'm having these microservices deployed into the cloud inside Docker containers. And this is the microservice picture. However, what the reality of this actually turns out to be is that I actually have pretty much control over these two services I'm pushing up into the cloud. You know, that's great, they're mine, I push up and deploy them. But going back to that original picture, this one happens to be about the other side of the world, you know, and honestly, calling it, I might as well actually walk there and make the service call myself because it's quicker than invoking this service because it's on a piece of string somewhere. And this guy, who knows what happened to this service? It could be anywhere. I'm calling it, I'm not getting an answer, nothing's happening. This is the microservice world. Except that what this is actually is this is a reintroduction of old problems of distributed computing. You know, this is where you have things that are, you know, people assume there's no latency on a network. The networks are all the same. Protocols are all the same. There's no failures on the network. And I can find things on the network. But suddenly when you have this microservices and microservices deployments, you suddenly find that these things aren't true anymore. My service has disappeared. It's running slower. It's running so slow, in fact, I'm not sure whether it has disappeared or whether, in fact, it's just being slow and it's going to come back to life again. Things come and go. So, you know, so we then had some new patterns. We call them new names for old problems at this point. So, you know, to handle this kind of thing, we have things like we have circuit breaking. So this is the situation where we're handling those services coming and going. We're going to retry. We're going to try and reestablish the circuit and call back that service. Ultimately, we have to decide what to do if we can't make that service call. So we have some fallback options. We have bulkheading. So, you know, this is, you know, in the monolith tended to be if something went wrong, the whole thing went down. Now we want to bulkhead our applications. We want to make sure if there's a failure in one aspect of our application, it doesn't bring down the whole service or we can cope with it. We also had things like we want the service discovery, and of course we want security. Remember back in the monolith, we own the network, we own the environment. Now we have those services. You go back to those services, that one halfway around the world, we need to share the same sorts of security. So how can that happen? So Kubernetes comes along, and that handles a number of these sort of more well-defined aspects of that Docker deployment. Remember, we're pushing microservices inside Docker containers into the cloud. But we need things like orchestration. We wanted to be able to say, okay, this service here depends on that service there. So I need you to start this guy up first before you start me up. So we have orchestration capabilities inside Kubernetes with stateful sets, for example. We have availability. So this attempts to address some of the aspects of this service has disappeared. Well, if the service has disappeared, Kubernetes will put it back. Of course, it doesn't actually help you if that thing just keeps crashing all the time and keeps putting it back. Kubernetes can keep putting it back as much as it wants. It's still not going to work. But it's a step in the right direction. It starts getting you some better availability. And finally, we have the scaling options. So Kubernetes is quite happy to be able to monitor CPU utilization, memory utilization. And if your service starts going over those limits, provided you've said it can do so, it will scale up another instance. So it started to address some of those more functional requirements of deployment to the cloud. But if you remember that list of things about finding services and circuit breaking and other aspects, these things aren't in Kubernetes. You still need to know how to find those services, for example. Okay, so frameworks to the rescue. So the frameworks have started to step up. They've started to introduce libraries. They've started to introduce code, which handles a lot of these situations. So for Spring, for example, they integrated the Netflix OSS stack. So they had Hystrix, which took care of your fallbacks for you. They had Ribbon and Eureka, which took care of some load balancing and service discovery bits for you. Spring Actuators, so this is health endpoints, logging, metrics, and Spring Security. So you can see the Spring ecosystem happily created libraries, created frameworks. The frameworks started picking up those gaps between that, okay, I've deployed stuff and things are available, but now how do I find it? How am I secure? What happens if things go wrong? Similarly, MicroProfile. So this is, for people not familiar with MicroProfile, this is the sort of community-led focus on defining some best practices and some standards and some ways of working with the Java aspects you need to be successful with microservices. So as you can see in this picture, this is from MicroProfile 1.3. They have JWT for security. They've got health checking. They've got the fault tolerance packages. So you have another, well-established Java framework providing these capabilities, these things that are necessary for a successful service deployment. The thing is, once you start doing that, you can get into the problem where you have the same code everywhere. You have a framework. Yes, the library may come as part of the runtime you're deploying in, or you may be compiling it in and deploying it inside, but it's the same code, and there will be an amount of boilerplate that comes around that code as well, and you're starting to perpetuate that through your services. And then, of course, we're microservices now, so we're polyglot. So at this point, we're looking to bring on, say, Node apps, Go apps, things like that, and we need the same libraries and the same frameworks for those as well. So assuming they exist and you can find them and you're happy with them, you've gone to NPM or whatever, you've got down a module for fallback or whatever, and you're starting to use it, you're starting to build up this inherent technical debt of support at this point. You've got all these frameworks out there, you have all these languages. If you want to change something, you want to fix something, you've got to go around to all your microservices and change it. So the question at this point, and obviously this is where Istio starts to come in, is surely the platform can handle some of this. The requirements we need are similar across every service. We have decisions to make about where we pick up and what we use inside the frameworks, but a lot of the actual requirements that we need are similar. So we have Istio. So you can find out more about istio.io website, which I think they missed a trick there. I would have gone for ist.io, but I don't know whether that was taken, but they've gone for istio.io, which sort of has me singing Old MacDonald every now and again. And what they've got is a platform way of addressing these issues that have come along with the way we're doing service development, service deployment. So just to sort of highlight some of the top-level things, they have an idea of a service mesh. So very top-level. Service mesh means I can say these services make up my application. So service A is part of my application. It could be part of this other application, this other one, but conceptually, I can say these services make up my application. We can do intelligent routing and load balancing. And a lot of what we're going to go through here will become apparent on how it's going to manage some of this stuff in a minute when we look at the architecture. It can do fault tolerance, policy enforcement, metrics logging, observability, and security. So it seems great, it can do all of this stuff, and how's it actually going to manage to do that? Okay, now this is Istio architecture at a real high level. I mean, the thing is, in order to what we're going to look at today in terms of what's provided by framework and what's provided by the platform, I don't want to get bogged down into what's actually inside, for example, like the control plane. I want to talk about the mixer and the pilot and other bits and pieces. So what we have here is a simplified version of the architecture. So because we're in Kubernetes, what we have is a service, and inside that service you have a pod. Okay? And deployed within that pod is your application. Now here comes the clever bit, as they say. So inside that pod is also a sidecar, which is called Envoy. And by sidecar, it's basically goes together, it's deployed in inside your pod at the same time as your application. It's in another container, but it sits between your application and the world. So all of your service calls route out through the Envoy, and the Envoys talk to each other and go back in. And the Envoys share information through the control plane, and the control plane enforces things like routing rules, policy. So all those things we talked about, this is how it's being done. Basically, what we have is Envoy is basically a C++ proxy that sits in front of your service and intercepts your communications with the outside world, and to a large extent controls the view that you have of the outside world. So hopefully you can see at this point, once you've actually stuck something in front of your service that's basically invisible to your service, you can, if you want to, start shedding some of the responsibilities into that service. So the circuit breaking, this can handle, your service can just make a call, and the Envoy can take care of the service breaking pattern for you. It can take care of various other things. It can take care of routing for you, and all sorts of other things. So the key bit, as I say, and also potentially, as Kate's going to talk about later on, some of the areas that's going to give you conflict and pause for thought and choices come around from this Envoy that's now in front that is effectively invisible to the application. So what I'm going to do quickly is just have a look at some code. I say some code. It's actually quite a lot of code. I'm not going to go through the code too much, but what I want to sort of cover and just sort of give you some appreciation, in case you've never seen it, some aspects of what's actually part of the code you'd be writing to deployment. So I have a simple example here. I've got a couple of projects I generated. I've got one with MicroProfile, one with Spring in, very similar bits and pieces. Just want to say, here's an example of the Spring actuator stuff running a health endpoint. Very simple, but you see it's part of the framework. It's being provided by Spring. Now, other things I have as part of this application, I've got a deployment YAML. So, on the left-hand side, you've seen this. It's actually opened up now, and you can see just how much stuff we have in terms of Kubernetes, we have in terms of Docker, we have in terms of Jenkins files, we have in terms of POM files, all sorts of mix and match between what's part of the framework and what's needed by the framework that you're building, and then what's part of the platform, how you're deploying it, whether it's straight Kubernetes or whether, as we have here, we also have Istio. So we have an Istio rule here. Now, we start off with this one. This is the one that's part of there that we turn on or off with a setting in our Helm chart and says, okay, if you want to deploy to Istio, you're controlling a large amount of your deployment and configuration through these deployment YAML files. And what's interesting is then you can start playing around with the routing rules. So here's a very simple example that I copied from the Istio websites in their documentation. And basically shows you how to do a routing rule that's going to basically route 25% of your traffic to version 2, 75% to version 1. So this enables you to be doing things like your A/B deployments. Now, I could have demoed this running, but I figured I wanted to get more onto talking about what this means rather than you watch a web browser that shows V1 on the screen and I hit it enough times and it'll come back with a V2. But the thing is, if you remember, you've got the Envoy sat in front. This is what makes the routing so powerful, but also and gives you those facilities. But also, once you understand the control you have with the routing, you can see how all those things is possible. And it really is sort of a matter of what routing rules would you like to apply. It's a fault injection. Is a routing thing. Here we go. So there's one that's going to randomly inject a delay in there for you, so you can see how your service is going. A further one down here, which is how we have things like routing based on specific headers. So we've got user JSON here. This could be a good example of canary deployment. Here's your test guy. You're just going to roll it out to one user, give it a sniff test, see how it looks like. This would just effectively route stuff just coming from that user. So there's a lot of power in those routing tables, and a lot of information and ways that you can control how Istio behaves to achieve the things that you want to achieve at platform level. So remember, because this is inside the deployment YAMLs, it's invisible to the application. So your application wouldn't know it's actually being deployed in something that's got fault injection, or it's got other routing rules that that intercept the traffic and maybe route it into different places. So go back to the slides. Okay, yes, as I say, part of the reason for showing you that was just look at how much stuff you get. Those were generated projects with code, and the problem is you're actually just given that, here you go, right? Out of all that thing, you notice it said, like, if you had Istio enabled, do this stuff. There's no actual guidance or help at that point of whether you actually want to use Istio or not. It just leaves it all up to you. It basically throws everything at you because it knows you may or may not want to do this stuff. So it gives you all the bindings, all of the scaffolding and everything else that you need to deploy your app, however you want to do it, but doesn't actually tell you how or what the consequences are of how you deploy that app. So I'm going to hand over to Kate now to run through exactly what those choices mean for you and how the frameworks and platforms interact, compete, and complement each other.
Thank you. Okay. So as Adam said, we've got all of these different capabilities that were originally provided by the framework, and then Istio's come along and said, well, now I can do this. And everyone's asking the question of, well, does that mean I need to throw out all the code that I just wrote to use the framework and just use Istio? What is there that's different between the two? So I'm going to talk through some of these capabilities that we've covered that's provided by both the framework and by Istio, and see how they interact together. Are there instances where they work really nicely, and are there instances where you have to kind of choose one or the other? So starting with service discovery. In a world where we're deploying to the cloud, probably with microservices, you can't rely on knowing exactly where a service is. And in fact, if you've got hard-coded endpoints, then you're probably restricting yourselves, because if you scale up to more instances, you can't call any of the instances that you've just stood up because you're hard-rooted to just one. So being able to discover where a service is very important. And this is something that's been important ever since we started moving to microservices. And the general structure that people tend to go for is they have a server that has a list of all the registered services that is in your application or that your applications need to know about. And then you have a client. The client communicates with the server. It's responsible for saying, this is where a service lives. And then at the point where you want to go on and invoke a different service, it handles that communication and that load balancing as well. So let's look at this in a bit more depth from a framework perspective. So we normally have two applications, say, defined, and we've got our service registry. And some examples of a service registry that you might be familiar with are Eureka, Console, Zookeeper. You've got that running up and ready to go. And so your application now needs something to allow it to talk to that service registry, to register itself and make calls. And the frameworks provide some libraries for that. So the one that a lot of people have heard of is Netflix, but Spring also provide integration with Eureka. They have an annotation that you can just use at Eureka Client, and then you're kind of all sorted. Your application can register with the service registry and say, this is my endpoint. It can also continue to send health checks to say, yep, I'm still running. You can keep sending requests to me. And then what the application will do is call the registry, get a list of all of the services available, and then say, okay, I'm going to call that one. So then it invokes it. And the key thing here is the application has the code that's doing the load balancing. It's handling it itself and working out which service to invoke. So if there were various different instances of that application, it's chosen one to go to. It might have arbitrarily chosen it, or it might have chosen it for a specific reason, but it's the application that's made that choice. So what about Kubernetes? So we talked briefly earlier about the idea that in Kubernetes you have your applications which are deployed in pods, and then you have multiple different pods that make up the different instances of that app, and you have a service which kind of defines that as a collective group. So if my application wants to call out, in Kubernetes we use DNS resolution, so it knows the DNS name of the service that it wants to call, so it calls out there. And then the service in Kubernetes handles saying, okay, in this instance, this is the specific app and the specific pod that I'm going to route you to. So it could go to one or other of the pods. And this can be done using just round robin or however you like. But at this point, the application hasn't actually had much say about where the call goes to. It's just called out to a specific service. The load balancing is all being done by Kubernetes. So we have these two scenarios, and Istio is then built on top of Kubernetes in this instance. So again, you call out to your app service, but here maybe you've defined some routing policies and you've said, actually, I deployed version 2 of my application, but that was a bad idea because it didn't really work. So we're still going to route all the traffic to version 1. So the app calls out to the app service, and then you say, okay, I'm going to send that to version 1 because that's the one that works. And so Istio is enforcing policies at this point on top of the general Kubernetes. So if you think back to the first picture, this is a long way away in terms of what the app knows about. In the first one, the app was making some decision about who to call. Here, it's not even Kubernetes, it's Istio that's enforcing policies. So we've got these two kind of quite different worlds. And if you have applications already, they've got their annotations to talk to Eureka, say, it could be tempting to just say, well, what if I take that and I just put it in Kubernetes with Istio? And one of our colleagues actually did try this just to see what would happen. So we've got this set up now. We've put Eureka in Kubernetes somehow, and we've got our Eureka service, which backs our Eureka. And when the applications stand up, they need to register with something. Because it's Kubernetes, it kind of makes sense that they register with their service. So we have a little list of version 1 of my app is at this service, and version 2 of my app is at this service. And so the app that wants to make the call first has to find Eureka, so it can use the Kubernetes service discovery to find its service discovery, which is slightly odd, but we'll roll with it. Calls out to Eureka and says, give me a list of services. I've got my list. I've decided that for whatever reason, I want to call version 1 of my app. I think that's the better version to call. So it says, okay, I'm going to call out to say I want version 1. But Istio got involved and said, actually, I've decided that we're routing to version 2 now, so the application gets routed to version 2. And at this point, the application actually thinks it's tried to call version 1 because it looked at the list from Eureka and said, well, I'm calling the one that was next to version 1. So the app might not even know that it's calling the wrong version at this point. So the app and whoever's written the app and whoever decided on the app side that they wanted version 1, they're probably not very happy. But the Istio team, whoever's maintaining that, are quite happy because policy enforcement is great. So as an app developer, you could say, well, how can I get around this? And there is a way around it, which is to register in a different way. So if I stand up my applications and register the IP of my pod, which you could do, then I have a list in Eureka of all of the different IPs. So my app calls out, goes and gets the list, and says, OK, I've got version 1 and it's at this IP, so I'm going to call it. And it does. It calls straight through to version 1, which is great for the application who wants to call version 1. But if there's a policy that says no one is allowed to call version 1, then that's not being enforced. So at this point, whoever's maintaining the Istio routing, they're like, well, what happened here? So there isn't an obvious kind of way that you can smush these two together and have them just work. There is a certain amount of you need to kind of pick one or the other, because as you can see, if the application thinks it's routing to a specific place, but Istio thinks it should route somewhere else, one of them is going to win. There is, however, some work being done in this area. So the Spring Cloud Kubernetes project is worth checking out. And they've been looking at what can we do with our Spring applications so that you won't have to change them too much, but they still work well with Istio if you've got things like Ribbon or Zipkin to do load balancing. They've also got some cool stuff in there around Kubernetes config maps, so that's how you define your configuration in Kubernetes, and mapping that to Spring config so that you don't have to update your application if you want to deploy it to Kubernetes. You can still keep using the same Spring config. So there's some nice things there, but it is still a work in progress. It's worth putting in a mention that this doesn't currently work with the Istio mutual TLS. For now, there's people working on it, I believe. But there is some work going on in this area. But for now, for service discovery, you probably want to make a choice of one way or the other. Otherwise, whoever's writing the routing rules and whoever's writing the app will probably have an argument over who wins. So next, we have fault tolerance. We talked earlier about in microservices, you want to be as fault tolerant as possible. And if an application goes down, you don't want to have everything go down with it. And again, this is a problem that's been addressed quite early on by the frameworks. So we have Netflix Hystrix, which hopefully a lot of you have heard of. We've also got the MicroProfile fault tolerance features. And again, these are libraries where you write your application code and you build the fault tolerance into your app. So your app defines, I want to retry this many times, or this is the fallback if this particular call fails. This is the circuit breaker that I'm going to have, etc. Istio, because of where it sits, because it's a service mesh, it's built into the infrastructure. And actually, Istio takes the standpoint of you should have almost no code in the application. So Istio will handle your retries, it'll handle circuit breaking. The only code that you have to write is if Istio comes back and says, well, I retried and the circuit's tripped or whatever, your app needs to do something about that when the request comes back having failed. The other thing that Istio does provide that is something that really the frameworks can't get involved with is fault injection. So it is possible for you to stand up a new app and have in the application code something that says, I'm going to just return duff information. I'm just going to pretend that I'm working, but I'm not really, to have faults. But then if you had a sudden surge in traffic, you might find things were routing to there that you didn't want to, or it can get a little bit confusing. So actually, if you can get Istio to do fault injection, it's much better because an application could call out, Istio can say, no, this application's down, even though it isn't. But then if you suddenly get a lot more traffic, Istio could pass that traffic onto the app that's running. You don't have to take any apps down or put up any bad apps to get faults in. So that's something that Istio does have that the frameworks really can't know about because they're just not in that space. So we've got these two pieces. And what happens if you put them together and just say, well, the app can do some and Istio can do some? There's a few things to consider. if you've got circuit breakers in two places, you can have a situation where one of the circuits trips and the other one doesn't. So if the app's doing circuit breaking and Istio is doing circuit breaking, and then Istio says, actually, I've decided that the app you're trying to call, it's not coming back for now, so I'm going to fail fast. Your application could keep retrying and making requests out to Envoy, and then Envoy has to deal with that. And it's not necessarily that bad because you're just calling out to Envoy, but it's kind of extra stuff going on that you don't really need. And with retries, it's a slightly worse situation because if the application is going to retry 3 times, but Istio is going to retry 4 times, the app calls, Istio tries 4 times and goes, oh no, that failed. And the app goes, oh, well, I've still got 2 more retries. Tries again. Istio tries 4 times, fails. You've suddenly got a lot more retries than you were expecting. And especially if you've got one team who's defining maybe your routing in Istio and another team that's writing the app itself, you might not be aware of the other people defining those retries. So you can have some pretty crazy behavior going on. So the key thing here with fault tolerance is you need to understand the flow of your request and who is doing what. You can't just assume that, throw them all together and they'll just work, because you probably will see some interesting things going on. Now, some of the frameworks have been addressing this already. For example, MicroProfile fault tolerance, you can turn off a lot of it and just leave fallbacks. So I said earlier that Istio needs you still to define a fallback as part of your app. There's an easy setting in MicroProfile fault tolerance to say, I want you to do fallbacks, but none of the other fault tolerance pieces. So you can do something like that. And there are things in the frameworks that are now coming to integrate better with Istio and with the fault tolerance here. But make sure you really know what you're doing. Next, security. So out of curiosity, did anybody come to our security talk last year? No, okay. We gave a security talk last year. You can go watch it on YouTube if you want to. But in that security talk, I went back and looked at the slides, and there's 3 key aims that we talked about that's actually quite relevant here. So these are the aims. When you're securing microservices, you need to know who are you, so who is the user that is making said request, and are they allowed to do that? Do I trust you? So this is service to service. Does the service that just called me, do I trust them to have sent me something good? Are they allowed to call me? And has anything changed in transit? So when you've sent a request, has someone actually muddled with the request that was sent? So from a framework and Istio standpoint, framework's got lots of different libraries. There's Spring Security, which provides some authentication and authorization, MicroProfile JWT authentication, and again, this code is built into the application. Last year, we also talked about using HMAX to hash your request to check if anything has changed or to check for retries and things like that. And all of this code was built into the application. In fact, for the game that we were talking about last year, it was a microservice-based game, we actually wrote a shared library for doing the HMAX so that we didn't have to write the same code everywhere. So the code is all built into the app here. And Istio provides service-to-service sort of level security. It provides mutual TLS, service-to-service encryption, and it's all service-centric is the key thing. And some of the things that Istio does provide, which is really nice, having tried to do it ourselves and struggled, is handling certificates. Because it does service-to-service, previously we were having to say, well, we'll create this secret between these 2 services, but then what happens if it gets revoked, and then you have to create a new one, and there's a lot of stuff there that you need to handle, but Istio will do that for you. I've got a question. Hello.
The support from Istio, is that only for services that all run within the same Kubernetes cluster, or does that go across as well?
I don't know if you can do it between different Kubernetes clusters or not, off the top of my head. But they will have to be running within the Istio, wherever Istio is. I'll find out, though, and I can let you know. So yeah, Istio is all service-centric. So the way I think this breaks down is really that the framework support links well to who are you, so that's with the JWT and things like that, and then you can do the HMACing, has anything changed, and then Istio, do I trust you, can the services talk to each other, which seems like a reasonable way to break it down, because as an app, I want to know, you know, if someone makes a request, it might be a perfectly valid request and I trust the person, but I then need to check, is the user allowed to do this thing? And that really is an application concern. Whereas, does this service, is it allowed to talk to this other service, is a platform concern. So that does make sense. Although it is worth keeping an eye out for this space, because if you actually look on the Istio website in their futures list, they have JWT in there. So it'll be interesting to see how this evolves and moves forward. But at the moment, I think this is how it kind of splits down. So now we have tracing, logging, and metrics. So again, we're in a distributed system. Trace isn't as straightforward as it could be, because you've got all of your different apps. How do you know who's calling who? And again, there's framework support already there and being used by a lot of people. So earlier, Adam showed the Spring actuator in action, having a health endpoint. Again, MicroProfile has the same thing, where if you turn on MicroProfile, I don't know what version off the top of my head, but it will just put you in a health endpoint for you. You don't have to write any code, the same with Spring. And also adding metrics, open tracing, a lot of those are available in the Spring actuator as well. And these are all application-specific pieces. So the health endpoint is something where you can then code in your app to say, this is what healthy means to my application, or this is what ready means. Then from an Istio standpoint, because of where it sits, it can intercept the network traffic. So it's a service mesh. All of the requests that go between the services are going through Istio because they're going through Envoy. So it's in a perfect place to actually track what's going on and actually to generate a service graph as well. So this is a service graph, which is quite fun, that you can get out of Istio, and it shows which apps are calling which, and might actually be a very interesting experiment for people to do if they're not sure which services are calling which and they want to find out. It can trace requests through the system, look at how long it's taking to call from one app to another. Again, this obviously links back into the fault tolerance, because if it's taking a particularly long time, then you could route to different services or things like that. But the thing that's worth noting is that actually, in order to get some of this tracing, you do need some Istio headers and things in your application. And so again, the frameworks are moving along and starting to integrate a bit with Istio. So with MicroProfile, you can have it with open tracing, you can have it injecting the headers that are required for Istio. And then it all works nice and you don't have to do it yourself. So although Istio sits in the perfect place to do all the network pieces, it can't do it by itself. It does need some interaction from the application. It does need some of the information passed back. And actually, both of these systems still need somewhere to put all of your logs. So something like Prometheus, which often comes alongside Istio, and a lot of people are using alongside their frameworks already, to put all of your logs in the right place and have them in a central place. So I've got under there app handling specific logging to the central system. But also on top, the application does have to define a health endpoint, etc. Kubernetes knows if a container is running or not running. It doesn't necessarily know if the app inside the container is working. So they're definitely, for tracing, logging, and metrics, you need to get a good harmony between Istio and your framework code in order to make sure that you're making the most of all the capabilities that are available to you. And if you do get that balance right, then you can get really cool diagrams like this one. Okay, so I'm going to pass back to Adam for a quick summary.
Okay, so I mean, what we've actually... don't think my mic's on. Have I turned? Oh no, I'm on now. Cool. So, I mean, what we've looked at is these overlapping capabilities and responsibilities in the space of the sort of non-functional requirement space of finding services, handling fallbacks, circuit breaking, things like that. And we've seen how Istio provides a number of these capabilities, but also how the frameworks have as well. And, I mean, hopefully what you take away from one thing is, you know, if we had a perfect world and you were starting from scratch, you could take what we've discussed here and you could say, okay, I'm going to put a little bit of fallback into my application. I'm just going to handle the fallbacking. I'm going to let Istio do the routing and the capabilities. I'm going to make these decisions here and now that says, when it comes out, we don't have a conflict anymore. We have designed this from scratch. Day one it comes out like that. But unfortunately, we're left with having to integrate with existing services. And if you just try and mash these two things together without any consideration, you're doing things at the platform level that are invisible to the app and things inside the app that are invisible to the platform. Hopefully, as you've gone through the scenarios Kate's outlined, you get appreciation of how confusing that is, how random it's going to be, and with completely unpredictable side effects of what you can do. I mean, I did call out earlier on about the framework support overhead. What's interesting is the actual introduction of Istio actually illustrates some of that. For example, if you wanted to shift some of this responsibilities into the platform, you've got to go around and change all your framework code now at this point. A very illustration of how you were quite happily with a piece of functionality deploying it, but you wish to change. You actually you actually have that problem now that in order to say leverage Istio, you have to go and change all your framework code. So I mean that is the main thing is it just comes back to that consideration of what's going to happen between platform, framework. Things are also going to evolve as well, so definitely keep an eye on Istio.io's website, the Spring website, and the MicroProfile website. And I'm sure there are others for other languages and everything else. I mean, Istio is gaining traction, becoming more popular. There'll be more libraries. There's going to be more integration. As Kate says, things that are tying up with open tracing, open API specs, all this kind of stuff is working together. Unfortunately, it's probably still not going to actually make it any clearer which one you should use when. It's just going to give you more options and more choices. But part of it is understanding those choices, understanding that your choices have consequences and what it's actually going to mean for you, and then making an informed decision rather than just saying, okay, we've got a new cool technology, let's start using this, let's be really, let's jump in and do this, because we can, because Kubernetes, Istio can be as simple as injecting it as part of your deployment, and it's there, but that's going to have potentially adverse effects and not what you intended. So, I think that's it. So, I think plenty of time left to get to the DevOps party afterwards. Just say thank you now, and if you have any more questions, just come and see us afterwards. Oh, in fact, one here, didn't you have to wait? Yes, you, sir.
So this framework is mostly, it seems, oriented towards when, like, let's say REST API, but when you have more like a choreography with message queues, and when service and all, they just send a message to a queue and then let the thing, and do you get the same sort of, or is it more for orchestration type?
At the moment, a lot of it deals with HTTP traffic, and for example, it doesn't. There are some capabilities you can't use if you're doing HTTPS out of your application. So it's definitely, I think, probably a space to watch in terms of as they keep evolving Istio, what they support. But at the moment, a lot of the capabilities are focused on HTTP. I mean, but it'd be interesting to see how it evolves.
I mean, as a general model, if you start intercepting traffic and communication out of your application, then you can start to do all sorts of things with it. So I think Kate's right. Istio's HTTP based at the moment. Going forwards, once you have that was almost that's the shift and the changer in this way. Is you now have something that's consistently sharing information, yet intercepting communication between your applications and your deployed services.
You could also argue as well in terms of where Istio might not be as useful, just playing devil's advocate, that if you're doing events, some of that fault tolerance pieces is sort of built in because you don't have to do a fallback because you just triggered off an event. So,
because I was thinking about the tracing when you use a Spring Cloud Stream. If you have some REST and then some message and then some REST, you will be able to see the UIDs in the span. You will be able to see the whole thing coming through. You will keep So I was wondering if the tracing was able to understand that as well. I guess you can configure the frameworks.
Yeah, we've only tried the tracing of service requests with HTTP. We haven't tried it with any eventing. So it would be interesting to see if it could handle it or not. Any more questions?
That's not all.
Does Istio provide any administration interface to update dynamically the values of circuit breaking or A/B testing or whatever, and without changing the configuration files?
So I think you would do it just by all of the Istio configuration files are Kubernetes YAML files, and they're designed to be able to be changed on the fly. You can do it via CLI commands, you can do it in the Kubernetes dashboard. I think that would be the obvious way to then go and move things around, because it's then Kubernetes.
So it's not like service-based. It's not in the package of the service, or the configuration.
Yeah, the configuration can be per service, but it's not necessarily tied to the life cycle of the service in any way.
Yeah, it's sort of a thing that travels alongside with your service as part of your,
So there's no need for deployment or whatever.
So, I mean, so we did have the thing on here where I actually showed you the Istio sort of deployment. So it can, it is part of. So you can do it with the, with the YAML files that you have here, but also you can do it with, a kubectl apply and inject the Istio configuration at that point in time as well. But as Kate said, at the end of the day, it's sort of, this is a very simple way of doing it. Standard Kubernetes dashboard, let you go and edit the service configuration, the routing as you need at that point in time.
The way you I don't know how familiar you are with Kubernetes pieces.
Yeah, I got what you mean.
But yeah, because at this point this is a root rule. It's kind of similar to if you just had a separate config map. You can update the config map separately to updating the application in Kubernetes.
Another question.
Hi, so as you're moving this functionality out of the service and into Istio as a magic component to sort of testing together, what kind of testing options do you get around Istio? Do they have much support for testing to the life of your application is now moving out of something that's unit testable and integration testable easily? Do they have much in the way of support for test frameworks or any ability to check that short of an end-to-end deployment?
That's a good question, which I honestly don't know the answer to.
No, I haven't seen that crop up.
I haven't. It's not something that they've talked about a lot. If it is a capability, in terms of general testing, though, I think there are two parts in terms of the generic testing that you would do when deploying to Kubernetes. Still stands in terms of you can test your individual application, you can test it with sort of mocks, and then you could stand it up in Kubernetes and test it. I think one of the nice things that it does add is you being able to put in, stand up a bunch of routing rules and fault injection rules, and send some traffic and see what happens. So I think there's added things you can do there, but I don't know if they have any specific tooling yet to manage that kind of thing or not.
Yeah, like you say, I mean, the thing is when you...
What was that? Okay, cool.
Yeah.
Apparently there are some options.
How close is this to being production ready?
So, Istio, according to Istio's website, yes, you can use it. It's offered offered as an option for installation and use as it is at the moment. I mean, it's an evolving thing like everything else is with new functions, new capabilities. But at the moment, it works. The routing rules are there. People are deploying on it. People are using it.
I think the key thing is if you look at the list of features and say, I'm going to use Istio for the things that it says that it does, yeah, you're fine. It's not in a position where you can just necessarily go, I'm going to take everything out of my application and put it all in Istio, because as we've demonstrated, some of those things don't come out. But for everything that Istio does, it's production ready.
Is that because that's what it says on the website, or is that based on your own personal experience?
I have not personally put Istio into production.
But do you know anyone who has? Because I doubt. I like the concepts a lot, and I think the vision is great. And I think much of these things should be in the platform and not be in the framework and the application. But I'm not sure Istio is quite there yet.
So I think...
There was a guy doing one of these earlier thing on Wednesday, and he said he was using it at Starbucks. We've been talking to a few people at Google who said wait for version 1, which isn't out yet, but is expected in Q3. So
Okay, so we're almost there.
Yeah.
close, maybe. Some people are like say some people are using it, then great. It's your own risk profile for your own purpose.
Yeah, so you have to test them.
Yeah, I mean, there is the Istio talk tomorrow as well. There's a guy from Google here tomorrow, Istio talk, so I would... Yeah, that's the guy. So, in terms of those kinds of levels of questions, then I think he would be very well placed to answer them.
Completely independent about it.
Yes. Yeah, of course. Yeah, I'm sure he's going to give the best thing. I mean, in the same way that we've tried to be independent and just present what we see as the consequences and choices between the available options that we're given now that we want to learn about, that we want to talk about, that we want to explore, without necessarily, I mean, although we titled our talk Spring, Istio versus Spring and MicroProfile, there's no really verses in there. There are choices and consequences, and we, as I say, we also try and be very fair in just presenting those choices with you and the consequences of them, but without sort of favouring or biasing in any way.
Any more questions? Okay. We will hang around for a little bit at the end if you don't want to speak up. But other than that, thank you very much.
Thank you.